Hi, this is Miss Litton, and this is my wonderful Period 2 class. Say hi. Hi. Say hi to 0 period.
Hi, 0 period.
This is for you, 0 period. We are recording the vertebrate nervous system. This is where we left off in the notes. This is section 17.2, titled The Central Nervous System. Okay, so big ticket here items. I put pants on him because I didn't want his junk out there. But when we talk about central nervous system, what are the two parts to the central nervous system? Brain and the spinal cord. Good. Okay, so take a look at this diagram. Central nervous system, brain and spinal cord. Everything outside of the central nervous system is referred to as the peripheral nervous system. Some of those nerves come off your brain. Those are cranial nerves. Some come off your spinal cord, spinal nerves. Now, of those nerves, some can be sensory and some can be motor. Which one goes away from your central nervous system? Motor. Which ones go towards your central nervous system? Good. Of those motor fibers, remember there's only two targets. What are the two targets of your motor, of any neuron going away? What are the two targets? Muscle or a gland? Okay. If it goes to your somatic nervous system, that's your skeletal muscle, and that's the one you control and you choose, unless it's a, what do we call that? Something like reflex. A reflex. Good. Your autonomic nervous system, this is smooth muscle, organs and glands inside, and you don't have to think about that. And while you're not thinking about it, sometimes it would make your heartbeat increase, sometimes it would make your heartbeat decrease, sometimes it would make your pupils dilate, sometimes it would make them constrict. That's your sympathetic versus parasympathetic. Sympathetic is fight or flight, related to adrenaline, stress. Okay, that's like right before a quiz, maybe it would be your sympathetic division where you're like, oh, I'm stressed out, or right before a game, or right before a speech, right? That's your sympathetic nervous system, fight or flight. When you're done, that's when you're chillaxing, that rest or digest. That's when you can take a moment and your muscles don't need to be all, ready to go. Your heart doesn't have to be beating faster. You can start digesting some food and relaxing. Okay, that's your parasympathetic division. We're going to talk about this part at the very end of this chapter, but right now we're going to focus on the brain, what it does to process incoming information and then send out outgoing information. So here on your central nervous system, you can see your brain and your spinal cord. And it is protected. It's cushioned by fluid and also by membranes. I'm not having you memorize the membranes, but it's the pia, which is the innermost part around your brain, the arachnoid, which kind of looks like a spider web, and the dura is the outermost. Do you see what that spells? P-A-D spells what? Pad. Okay? It's padding. So there's fluid on there, and there are membranes that protect it. When you look at the spinal cord or the brain, you will see gray matter and you will see white matter. The white matter is white due to that myelin sheet, that insulating layer. The gray matter is gray because it's a bunch of cell bodies all together. And in the spinal cord, this kind of looks like a butterfly, and it's like this person is facing down and you just chopped off his body right here and he's laying down like this. And what happens is sensory information, sensory neurons, come in the back of your spinal cord, and motor neurons go out the front of your spinal cord. And once that sensory information comes in, it'll synapse with an interneuron that will go up to your what? Brain for processing. So look on your group shared notes real quick and go to central nervous system, introduction. The function is sensory information is received and motor control is initiated. The meninges are protective membranes around the CNS. You have cerebral spinal fluid that fills the spaces and cushions and protects the central nervous system. When you look at the spinal cord, the gray matter is cell bodies of motor neurons and interneurons, and it looks like a butterfly. The white matter is myelinated neurons, and in the very center, this central canal has fluid in it, and that is cerebral spinal fluid. Okay, let's take a look at it from this angle. This person is facing us. The sensory neurons are coming in the back. Motor neurons are coming out the front. So sensory is going in here. Motor neurons are going out the front. And if I went and grabbed all your nerves, you have 31 pairs of nerves coming off your spine. They are all referred to as mixed nerves because they have both sensory and what? Motor. That's why they're called mixed nerves. Coming off your brain, you have 12 pairs of nerves. Some are sensory, some are motor, and some are mixed. The function of your spinal cord is reflex actions. It sends sensory information to the brain, and the tracks cross over. If you look here, did I talk about the hot cookie pan already? Okay, so here you can see sensory information coming in the back, motor information out the front. The reflex part of your spinal cord, if you touch a hot cookie pan, and hot, it's probably like 375 degrees because that's what it is for cookies. Sensory information comes in. It synapses here at your spinal cord with two kinds of neurons. What kind of neurons do you find in your central nervous system? Starts with an I. Inner neuron. It'll synapse with an inner neuron that's going up to your brain for you to process it, but it'll also synapse with a motor neuron that goes to your bicep. And if you have a really strong stimulus, like a hot cookie pan, it'll synapse with both simultaneously, so you will actually pull your hand away from that hot pan, and then you'll go, ow. Why would that be an adaptive response, not to wait for your brain to process it and then send it back out? Why would that be a good adaptation? Yes?
Because it keeps you from keeping your hand on it.
Yes, if it's super hot like that, right? I don't want to leave my hand on here and my parietal lobe, I go, oh boy, that's a really hot pan, and it sends it to the front of my brain and my motor area, and it sends it back down, and then I pull away because I'm going to have more damage. So that's why reflexes happen really fast. If somebody was throwing a brick at your face, right, you don't want to have to go, hey, look, I think that's a brick, maybe we should, okay? But instead, a reflex, if it sees something coming at you quickly, then you're like, huh, and you dodge it, you don't even process it. And that's what your spinal cord will do for you. Now, if you have damage along your spinal cord, depending on where the damage is, depends on how much of your body that you can move and you can control. If it's farther down, then you'll have more movement to your body. Higher up, if the lesion, if that's where the break is in your spinal cord, you lose more of your sensory and motor function. Moving into your brain, take a look at your brain. Okay, so right here in the front, the whole front, this is where motor information in the front is going out. Similar to your spinal cord, the motor neurons are in the front, and here in your brain, the motor area is in the front. Okay, the sensory information is right here. This is where you process at your parietal lobe, and then your occipital lobe is in the back of your brain. I could make you blind two different ways. I could like gouge out her eye. I would never do this. I could gouge out her eyes so her receptors don't work, or I could take a hammer to the back of her head right here and destroy her occipital lobe. Either way, she wouldn't be able to either process it or perceive it. You see the difference there? Okay, your temporal lobe right here, this is all about hearing and also language as well. This whole portion of your brain right here is called your cerebral cortex. This is memory, learning, and thought. Could you survive without that? You could. You absolutely could survive. When people are alive but not responding to or moving their body, what is that called? Brain death, or they could be in a coma, right? Inside, you know, deeper in your brainstem here, you know there's something that controls your heart rate and breathing. What's that called? The medulla oblongata. Yeah, that is your functions that keep you alive. This is the quality of your life, right? And being able to respond. So when we break down the brain, here's another picture of it here. They actually know which parts of the brain process which information from your trunk or your mouth or your lips and send that information back out. This part right here is called your cerebellum. Your cerebellum takes the information that you have from your motor areas and it fine-tunes it. I remember the cerebellum like Sarah the ballerina. So your frontal lobe might just tell you to move your arm in front of you and to the side. but your cerebellum will coordinate that movement so that it's, a little bit better, I guess. But even your speech, it coordinates your lips so you sound in an understandable way. If somebody drinks alcohol, what can happen to their speech? It gets slurred. The reason is alcohol affects the cerebellum, so you cannot pronounce your words as well. What's another test they do if you've been drinking and driving? What do they have you do? Walk a straight line, okay? Your frontal lobe will tell you touch your nose, but if you're drunk, right, you have trouble. Or count backwards. This is where you're processing and organizing your response, being able to walk that straight line and not falling over. Your cerebellum is impacted by that alcohol, and so you cannot coordinate your response and you might fall over. Okay, that's your cerebellum right here. This is just a diagram that shows you how much of your brain is dedicated to each of those areas. Is your primary motor area. What does it seem like is really important to your cerebrum based on the size? What's big on there? Hands, what else? Your face, right? On all of our expressions in our face and how we communicate, and your tongue. If you look here, you can see your sensory area where we dedicate a lot of our senses, how much of our brain is dedicated to those different senses. Looking here is a cross-section of your brain. There's some things you're already familiar with. Your pituitary gland is right here below your hypothalamus. Your cerebrum, memory, learning, and thought, we just went over that. Your thalamus right here that looks like the fried egg above your hypothalamus, this is where you connect emotions with smell. And other sensations too, but smell is a much larger sense than anything else. It's a chemical sense. This would be like if you smelled a perfume and it reminded you of somebody. Or you might hear a song from when you were in 8th grade and you're like, oh, I remember what I was doing then. Okay, all of that kind of links to memory. That is in your thalamus. Your cerebellum, I already told you about, coordination of your body. Here in your brainstem, you can see your medulla oblongata. This is your heart rate and your breathing. Okay, I want to get a few of these down. Go to the brain. The cerebrum, the big part on top, receives sensory information and integrates and sends motor response. It communicates and coordinates the entire brain. It does sensation, reasoning, learning, memory, language, speech. The diencephalon, di means two, is your hypothalamus, and your hypothalamus is all about what? Homeostasis. Who does the hypothalamus control? Pituitary gland. And your thalamus that looks like the egg above it, the fried egg above it, that's about receiving senses. So hypothalamus, the key word there is homeostasis. Regulates hunger, sleep, thirst, temperature. The hypothalamus is the link between the nervous system and the endocrine system by controlling the what gland? Pituitary. And the thalamus, I gave you that one. Your cerebellum integrates and passes on both sensory and motor information. It maintains normal muscle tone, posture, balance, and coordinated movement. And then right here, your hind brain, we kind of went over this a little bit already. Your medulla oblongata regulates breathing, heartbeat, blood pressure, vomiting and sneezing, in case you want to. And then the pons works with them. Okay, so all we have left is 17.3 and 17.4. We've gone over part of it, but we have some more on that. And I want to do a little bit on drugs and disorders, but I've given you almost all of that one. Okay, so we'll do the rest of that on Monday. What are you doing on Thursday? Lab. And you're going to finish it and get it done. So when I see you on Monday, we finish the notes, and then we spend the rest of the time reviewing for your test on Wednesday. Remember, it's a partner test. Don't let up off the gas just because you have a partner, right? Don't let up off the gas. K0, hope that was helpful.